Good evening, everyone, and welcome to Agent Night. We are so thrilled to have you all here back at the Regency Ballroom. We've done a bunch of events here. This is going to be the best one yet. We are so excited. So, quick agenda for tonight. First, we're going to talk about something new we've been building at WorkOS around agent permissions. This, we think, is the next big problem for all of you building agents and for the world, and really what's needed to take agentic software to the next level. After that, we'll jump into our lightning demos. These are demos from people building new products, new startups, new ideas, folks in the community that we want to showcase. We'll switch then into a panel discussion with some folks that have been building agents, investing in agents, running other events. It's really excited about that conversation. Last but not least, for all of you, we'll be throwing you an after party. Please stick around for that. It's literally right downstairs from where you are. We'll have a bunch of food, drinks, and I think our secret underground chess tournament has come back. So for all of you chess heads, game on. Agents have changed dramatically over the past year, even really over the past 3 to 6 months, but really over the last year. If you think about where we were maybe a year ago as people were building things with MCP and with other systems, the way that we were working with agents was really single player. Agents would work alongside a person. Back then, they might not even be called agents. It was just, you prompting ChatGPT or prompting Claude, but it worked alongside a single person. It was kind of your copilot or assistant. Today, though, agents aren't just writing code. They're not just right next to us. Agents are doing so much more. They're doing research. They're analyzing data, coordinating projects for us. They're probably preparing customer meetings. They might be making your presentations for you. They're actually handling operational work. And they're doing it across the full organization. So no longer is it this single player mode. It's really teams of people using agents together. And I think the biggest change here is really that agents are becoming capable of taking a lot of real work off of our plates. This isn't just another interface transition like I think desktop was or like mobile was. Desktop software, when we went to PC or cloud, it gave us better tools, and mobile made those tools available to us everywhere. You could have it on your phone at any moment. But those were primarily just about giving you more access. Agents really don't just augment your work, they amplify your ability to do things. It's really having these like AI coworkers, which we'll talk about in a little bit. Ivan Zhao, who's the co-founder and CEO of Notion, they've been building a lot of stuff in agents over the last year. And he wrote this great post where he talked about using agents, the experience as being a manager of infinite minds. I really love this phrase, like the idea of being a manager of infinite minds. You can spin them up, you can send them on different tasks, you can collaborate with them in this very natural way. The infinite minds part might be the compelling piece of this. You imagine this fleet or this huge population of geniuses. But I think that actually the load-bearing word here maybe is actually manager. We're all managers now. In the previous way of working with agents, you had that single player. Today, as a person, you're the one orchestrating a team of agents. You act as a manager. You're operating with a higher level kind of executive function. You're planning the work for them, you're coordinating. And I think we're all feeling this. If you feel in your job that it's more exhausting than before, how many of you feel like work is harder now? It's probably because you're all managers, and management is exhausting. It's a lot harder. You have to keep a lot of things multi-threaded and have a lot of context that you're running between. The things that you might be doing include defining goals, telling the agents what they can actually go do, providing context, giving them information so they can make decisions and reason, reviewing the outcomes. So after the work gets done, did this actually match your goal? Is it good enough? Or do you need to take another turn at it? And then teaching the systems, not just providing the outcome feedback, but actually educating it, saying, hey, that wasn't quite right, or I need you to operate in this way or behave in this different way. And this is really the loop that, if you've been a manager for a while, this is what you'll do with a team. And now, all of you being managers of agents, this is probably what you're doing as well. We've moved from executing work, if you're an IC, doing the work, to orchestrating work. And I don't think we're going to go back. I think the job of just being in the IC execution, just like kind of a factory worker, is gone. It's higher leverage to be able to manage agents, and people that can't make this adaptation won't be as productive going forward. So this is a big shift in how we just get work done. I think it's actually a huge shift in how companies can operate and what our jobs will look like. Now, the biggest place that agents have had impact, the biggest impact they've had by far is software engineering, hands down. We've seen it across the board. Products like Claude and Devon have accelerated and revenue has exploded. And I think the reason why is because coding, software engineering as a problem, is kind of perfectly fit for agents. It's actually already kind of perfectly designed for agentic workflows. Coding agents, they already have a dedicated runtime. They have a shared context, the code base and the CI and the integrations. They have documentation, they have tests, they have a terminal, like an interactive element where you can do stuff, feedback loops, version control. They have all these things that are kind of built in that allows agents immediately to engage with them and start writing code and building stuff. And so it's actually quite easy to take a coding LLM or a coding agent or a harness and stick it into the system and have it be productive. The guardrails are already set up. So I don't think it's an accident that software engineering was the first place that we had this explosive growth of agentic human collaboration and the kind of productivity outcomes. And obviously, software is also really valuable, so it's worth paying a lot of money to automate this. Enterprises don't have an equivalent operating environment. Like normal jobs, non-coding jobs, just like a company. If you think about a company instead of a code base, this doesn't really exist. And I think they don't have it yet. When people talk about building company brains or context layers or all these things, a lot of what we're trying to do is take the principles of what makes software engineering work really well and apply it to how we structure how organizations operate. Instead of performance reviews, you have evals for teams or people, right? And if you can shape the way that you work into this, you can actually deploy these intelligent systems to get the same outcomes. So what do enterprise agents need, enterprise companies to run agents? Well, you need a place that the work can persist. You need shared memory and process and skills. That's kind of the execution, to-dos of the organization. You need safe access to the company's systems. Inside of an enterprise, there's gazillions of different things to integrate with, fragmented systems. It's not just, the code base, it's all these different places, people, places, things. And then, importantly at the end here, you need a way for people and agents to work together. I don't think we're going to enter a world where people don't engage with the systems. We've already seen this. We're working more than ever before and harder than ever before. Humans will be a big part of this. And so what is that interface fabric? What is the kind of matrix that we sit on top of with the coding agents or the other agentic systems? So we think that this is kind of the stack of what enterprises need to transition into this AI world. You need to change the way that they operate, change the way that they kind of make decisions and execute. We've been building a lot of components around this over the last year at WorkOS. We've been thinking about this for quite a while. And we've been trying to build it up kind of brick by brick. So, a year and a half ago or so, maybe closer to 2 years ago, we launched a product called Vault, secure encryption for any data. You could put secrets into this, you could put sensitive data, you could isolate it from some certain systems. Last year, we launched a product called Pipes, which does integrations. Every agent needs to integrate with all your stuff, connects to all the different various services, does the OAuth dance for you. And then most recently, we launched the thing called Relay. And Relay is this thing built on top of Pipes and on top of Vault, and it actually lets your agent get access to all this stuff without exposing any of the secrets. So your agent can run in a sandbox and just connect to these services, and there's never any credential that could be leaked. So it's pretty powerful. These are like the building blocks together. And in addition to building these products for all of you, for developers building things, we've actually been building agents internally at WorkOS for the last 2 years. I think back then we called them Slack bots and different systems internally. And we built a lot of stuff for the engineering side in terms of our engineering process. We also built a lot on our go-to-market side. We have a whole go-to-market engineering team. But we've been building this actually to change the way that we operate and work. And last week we announced this actually publicly with a new app we built called Atlas. And Atlas has been our internal agent. It lives inside of Slack. We all use it every day. It changes the way that we work. It integrates with everything. And all of you can use it too. We've been building it for ourselves, but we just open it up to other people. And if you haven't tried Atlas, it's pretty awesome. You just add it inside of Slack. You can chat with it like a coworker, and it can do a zillion different things for you. You can have it onboard people. You can give it have it give you an overview of your day. You can have it do an analysis of different things. You can have it run on routines every morning, check something for me. I have it go scrape all of our customer support threads and send me a summary. It's really easy, and I don't have to write some script or some crazy, different language. I don't have to figure out how to run it. I just tell it what I want to do. I interface with it naturally, like a coworker. It's really powerful, really, really powerful. It has shared memory. It takes real actions. Most importantly, it actually learns from you. So as you use it, it's adaptive. You can correct it. You can say, not like that. I want it just like this. And the memory sticks over periods of time. Probably the most important thing about Atlas, like the reason it's able to do this, is how it integrates with everything that you use. Because Atlas is built on top of what I showed earlier, Relay and Pipes and Vault and that whole stack, it actually connects everywhere to all of your stuff. Pretty awesome. Connects over 200 services. I think this week it'll be 300. So it's pretty much anything you're using. You want to bring that data in and have it do interactions, change stuff, Atlas can do it. It even has a generic connector. So you can tell Atlas, go figure out how to integrate with this thing, and it figures out how to do it. So you can query anything, you can do anything, but maybe you don't actually want your AI overlords having access to everything. That's kind of the question. As we use these systems and they become more and more powerful, and they become the primary way that we work, we'll want to give them access to everything. We'll want to give them the tools to actually change things. But where does security come in there? How does authorization work across teams? What about how different groups of people work together or different individuals? How do you make sure Atlas doesn't leak your private data in a group context? But in a group context, it can actually maybe have the intersection of the user data. It's this very hard problem around permissions. And so we found actually the secret to making agents safe and secure is not just the LLMs, it's not just the models, it's not just the frameworks, it's actually the authorization system, the underlying permission and access control system. That's the hard part. If you get that wrong, it can be disastrous. You can immediately lose trust in the agents. They can leak data or go off and do destructive actions. But if you get it right, you can trust this thing with nearly anything that you can do, right? So it's really important, this authorization system under the hood. And we found no one had really cracked this. People had built agents that work in a private context. If you use ChatGPT or something like that, it runs just for you personally. And then people have cracked agents in a shared context where you have global connectors for everyone. But what about the things in between? How do permissions work for that? And how can you kind of dial it in exactly to what you need? If you've studied permissions, or you may have heard some of these acronyms, going back, role-based access control is how we do this with people. So you have humans as part of teams. You assign a role to that team or that person, and that role comes with a set of permissions. A role could be admin, it could be member, it could be developer, and they have different capabilities. So you're associating capabilities with a role. Problem is that's not actually that granular. Roles are pretty coarse scoped. It's usually your job function. It's not for like a specific task. And for agents, they need access to like everything. They need to be able to see everything and do everything. So there's another authorization system that we provide as well, for many years, called FGA, fine-grained authorization. So this is really granular, like different resources, different entities. You can think about it like this document or that folder or that GitHub repo. And this is another way to represent the actual object structure. You think about it as like this big tree of all the data, who gets access to what. But the problem is it's static. You can't change. And agents aren't static. They're anything but as they run. They evolve, they change what they need to do over time. So we found actually both of these weren't a good fit. You can't use RBAC, you can't use FGA. You need something different for agentic permissions. You actually need like a different animal for this. And just to go a little deeper into the reason why, previous authorization systems were designed for static permissions. So if you've ever heard about this, the principle of least privilege, this is like a term in computer science for people building distributed systems. It's the idea that when you write code and you have a system that runs, you give it a credential that's scoped down to only that data it needs to access and nothing more. And you can do that because you can look at the code that's going to run, And you can say, okay, it's only going to access these 3 things, so I'll give it a permission for those 3 things, and I'll bake that, and that's it. This doesn't work for agents. Because if you prompt an agent and you say, go off and do this thing for me, you don't know what systems it needs access to. It doesn't know. There's no way from the initial intent from the prompt to figure out what systems it should have access to at like compile time. Think about it in that way. So this worked really well for declarative code. For systems at compile time, you could look at the permissioning system. But the principle of least privilege doesn't actually, applied. It's not effective in this world of non-deterministic agentic software. Agents are introducing a dynamic principle. The agent itself is not static. The permissions cannot be static. And so you need this ability to have the permissions be discovered at runtime. As it's going, it's able to figure out the permissions and navigate that. It needs to be able to figure this stuff out. There's really 2 worlds today for permissions. If you've used something like, Claude Code, on the one hand, you have manual approval. This is probably how all of us started using things like Claude Code. It asks you every single time what to do. Can I run the git command? Can I change the directory? Can I do this? And you hit enter a few times, but I'll be the first to admit, I got kind of sick of this after a while, right? And then I went full YOLO mode. Yeah, dangerously skip permissions. And you just approve it and you say, Jesus, take the wheel. I hope to God Claude doesn't delete my home folder, doesn't corrupt my file system, doesn't destroy my laptop, I don't know what, right? I have so much sensitive data. But the reason why is because there hasn't been anything here in the middle. I can't go manually approve everything. That's crazy. That's nuts. Maybe some of you do. I can't do that. But the YOLO mode doesn't feel like a very good option either. And if you're running it just locally on your Mac or on your computer, and you're using something like Claude's auto mode, which is pretty good, maybe it's able to scope down and remove destructive actions for your computer itself. But what about all the third-party services you're interacting with? Auto mode doesn't protect you against that. It might stop you from deleting your home folder, but it won't stop you from deleting 1,000 Salesforce records in your CRM. And so we think you shouldn't have to choose one or the other. These 2 extremes are pretty dramatic. There's a pretty big space in between them. There should be something in between. Something that actually allows you to have dynamic permissions that can be adaptive to the type of prompts that you have and can help your agent navigate the permission landscape. It's this thing that sits in between the 2 worlds and creates a sense of security and safety where everything is governed and auditable, and actually something that you can trust and depend on. And so this is what we've been building over the last year or so in a lot of different forms. And we're calling this WorkOS Airlock. And what Airlock does is a new form of access control that we're calling intent-based access control, IBAC. And what this means is rather than having a role that gets assigned, you have an intent. And the intent here is what the agent's trying to do, what task you send it out onto, what mission it's going out into the world. That's what encapsulates the permission. Because you're essentially saying, I want this agent to be able to accomplish this thing, and that's going to be what the permissions derive from. So how does this work? How does Airlock actually work? Well, access is evaluated from this intent, like I mentioned. It starts off with that prompt. So the intent begins as a prompt. You're saying, I want to have this outcome. Say, for example, send an email to Joe with the latest financial forecast. I'm not sharing a folder with it. I'm not saying you have access to delete all my email or read my email or whatever. I'm just saying the thing I want it to accomplish. From the intent, we're actually able to kind of extract, to compound, to compile, in a sense, the action. And that action includes the intent and connectors and like the action definition, what you're actually trying to accomplish from it. We expand that in the system. And then third, you actually do the permission evaluation. So as it's running, your agent is sort of negotiating with Airlock around what access it gets and why. And that permission evaluation can result in approval. Hey, you're good to go. You can send this message to Gmail. Denial. No way. You can't delete all this stuff. You were just going to send an email. What are you doing? Or approval needed. Hey, this is in the gray area. We should escalate it to a human or bubble it back up. Or I'm not able to make a decision here and I need more information. This is actually intelligence inside an access control system, which we've never seen before. In a sense, actually, the problem with permissions for AI agents is going to be solved with AI, with more AI. This is a new powerful model that we think is going to be the backbone of how permissions and authorization works in the era of AI. And I think there's no better way for you guys all to see this than a live demo. What do you think? All right, we'll keep that applause going for our very first live demo of the night for Aaron Tainter from WorkOS, who's been working on Airlock. Take it away, Aaron.
All right, yeah, my name's Aaron. I'm an engineer on the authorization team at WorkOS, and today I'm building out my Acme agent harness. And I want to give it a new capability to send and view emails. So I've already got my WorkOS pipe set up, and that was pretty easy. Pipes connect to a bunch of different data providers. They manage my OAuth credentials for me. The thing that has me a little worried, though, is I have this pretty broad scope on the pipe here. So this is basically everything that Gmail will allow it to do. So I can send emails, I can read emails, I can delete emails, I can look at all the inbox settings and all that. And that's a lot of responsibility to hand to an agent, especially because you can't unsend an email. You could leak sensitive information. You could send the wrong email to the wrong person. And of course, if the agent does anything wrong, it'll tell me I'm absolutely right to be upset about it. Okay, so I'm going to put everything behind Airlock instead. Airlock sits between the agent and WorkOS pipes, and it kind of governs what the agent can do through running both deterministic and non-deterministic policies so that your agent doesn't go off the rails. So I already have Gmail and Linear connected here. I'm just going to hop into rules. I already have a few rules in here. And there's one around prompt injection. I've got some here for Linear and Notion, but I started drafting out some instructions for Gmail, so I'll just go ahead and paste those in there. All right, so this brings up the rule builder, and what the rule builder does is it translates my instructions into policies that Airlock can understand. Those are both deterministic and non-deterministic policies. While this is translating, let's read through some of these so you know what's going on. So the first one is I want to allow my agents to read emails. I also want them to be able to send emails as long as it's only going to a single recipient or just a few recipients. However, if I'm sending an email to a distribution list that I've never sent before, that probably needs an approval, right? Because I don't want to just bulk send, some email to a bunch of people. So that goes through an IT admin, and IT admin is just like a role that we have in WorkOS. I also don't want my agents to be able to delete mail, but they can delete drafts. And then there's also some restrictions around what's in the body. So no secret data, credentials, API keys, financial data, token spend, phone numbers, and I want to make sure the recipients match those addressed. Okay, so it looks like it created a few rules here. First rules are the deterministic rules. These kind of gate which API endpoints your agent can hit. And you can put constraints on the method, arguments in the body. You can do comparison, you can do wildcards and all of that. And they just kind of control what your agent can do within the API. You can also deny things. Say you have like broad access over a certain sub endpoint, but you want to deny another sub endpoint beyond that, you can do that. But I think what's more interesting is the runtime rules. And these rules are non-deterministic policies that get run in Airlock through an agent. And it kind of governs the API call. And it's used for things that can't easily be expressed with deterministic policies. So things like looking at secret data or determining if there's financial data. It's kind of hard to write deterministic policy that will do that. So it's done within this layer. It can also do multi-step lookups. So if you remember, I was talking about the distribution list. In order to figure that out, the agent needs to look at your inbox to determine if you've sent to that distribution list before it passes the request through. So I'm just going to go ahead and create rules, and let's start sending some emails. So we'll go back into the Acme agent, and I'm just going to do a simple one here first. So I'll say, we're going to do some work in Gmail and Linear. Send an email to my manager, Pavan at workos.com. Let him know that Q3 planning is in Linear. Okay, planning is in Linear. That looks good, so let's just hit OK. And while this is working, I'm going to go back into Airlock and click on the Activity tab. The Activity tab is a place where you have all the audit logs for your agents. So you can see the agent activity by session. There might be a bunch of actions within that session, so it looks like one pops up here. And how Airlock works is the agent will request a token from Airlock for an intent, And so this case, the intent is working in Gmail and linear, reading linear issues, sending emails, and it will send back a token. And the token is used to call the linear APIs. It's used to call Gmail APIs. The Airlock will basically look at that token and the intent in the token, make sure it aligns with the calls that are being made, and then it will pass them through if they also pass the policies. So it looks like it looks through linear, got some issues, sent an email, and everything was okay. Didn't break any of our rules. And we can confirm that if we went back here. Okay, cool. So let's see what happens if I break some of my rules. If you remember, I had some rules around financial data. And I've seen this before where you might have an agent that goes and fetches some data, might read some confidential information and pipe it out somewhere else as a security vulnerability there. So we're just going to have it read an issue in linear that has some token spend information and send it to one of my coworkers. Okay, so now I want you to look in linear, find an issue called LLM tokens, and then send it to my coworker, a summary to my coworker, Colin at workos.com. Colin at workos.com. Okay, so let's see what happens if I do this. All right, so the first thing it's doing is reaching out to linear, and this is still within the intent here, so we should see some more logs popping up here. Okay, so it looks like it found that issue, and now it's sending the email. Okay, so it's judging against the org policy. And there it goes, it's denied. So the email contains token spend, financial data, and it was blocked. Yep, okay. So yeah, if you can look in here and see some information about why it was blocked. But yeah, so the answer isn't always yes or no. Sometimes you need an approval from a human. So if you remember, we had that the rule around distribution lists. So I'm going to send one more email, and tonight is WorkOS Agent Night, so I think it'd be great if we gave all the WorkOS employees tomorrow off for all their hard work. Yeah, okay. So here we go. Tonight is WorkOS Agent Night. I want to give tomorrow off to all of the WorkOS employees. Send an email to staff@workos.com and thank them for their hard work. Okay, so I haven't sent to staff@workos.com before. So let's see if this approval goes through. Looks like an approval is required. Good thing I'm also an IT admin. So let's go into Slack. And hey, looks like I got notification here. So it says, send an email to staff@workos.com with the subject, thank you, plus tomorrow off. Oh yeah, that looks good. Michael, what do you think? Should I send it? Should I send it? All right. Woo, now everybody has tomorrow off. Great. All right. It's sent. Okay. So yeah, everything so far has been through Gmail and linear, but obviously it works with all of your WorkOS pipes. I've integrated this with my own agent harness, but it also works in MCP, and it will be available in Atlas. So I just want to say thanks, and I'll hand it back over to you, Michael.
So we've been building this for a while. We're super excited about what this actually enables developers to do. It's a way to express this much more complex, nuanced permissioning that agents actually need to operate. You can't have just a static permission definition that works for agentic systems. It just doesn't work. There's not enough granularity ever in the universe to represent all possible intents you could ever have. And so you actually need AI to be able to look at this, to evaluate it based on policy, based on declarative systems, and then surface it to the end user when they need to approve it. Airlock here, what we just showed, provides the agent identity, so it's be able to give that token to the agent. Delegated authority, you saw a demo of that as well. Intent evaluation, taking the goal, the intent, and kind of computing it into the end state. Dynamic permission decisions, capability declarations, of course, normal things that you'll have in authorization systems like approval workflows, credential brokering, so the agent itself never actually sees the tokens for these end states. Because like the Gmail token, in that example, is too coarse scoped. If you just gave that to the agent, it'd be able to do everything. So it's this gateway that's actually pushing everything through. And of course, everything is audited. There's adaptive policies. This last thing here, this is really what this is all about. It's like autonomous software governance. It's the ability to actually have security governance on top of these agentic systems and just have it run autonomously all the time. So this is really, really powerful stuff. We think we've cracked it. I remember working on this with Aaron a few weeks ago, and kind of the light bulb moment went off, and we were like, this is it. I think this is what's going to work. The key thing here is really bringing these two worlds that have been separated for so long, deterministic permissions, meaning that declarative list of capabilities that are your deterministic code, and then non-deterministic agent execution, which is how agents will go run and execute. What we've really done is brought these two together. Airlock is able to sit in between and allow your applications to work in both of these regions. People have built systems for either side of it, but bringing these two together is kind of this like grand unified authorization system. So we're really, really excited about this. In particular, Airlock also works everywhere. If you're using something like Claude Code or Pi or Codex or Open Code or something like that, Airlock can work great there. You can add all of your connectors, all of your systems to it. It can work with OpenClaw, it can work with Hermes, any of these systems. But also, it can work with any MCP gateway. So if you already have a bunch of MCP connectors that you want to bring in, you can do that too. You can just connect Airlock to it as this intermediate and express policies and intent inside of that. And last but not least, it actually also works with AI teammates. So Atlas, which we talked about a little bit earlier, the permissioning model for that, as you saw in Slack, the approvals can come right through that. So for people that are not writing code, their primary app that they use every day is usually Slack. That's how they coordinate on teams. That's how they interact. And so we think it's really, really, really important that these workflows, these permissions, these approval flows don't just live exclusively inside of your coding system or inside of your IDE, that they actually can live with your team does, which is inside of Slack. And so Airlock also works inside of Atlas, and we're going to be adding a lot more features to it going forward.